Hello everyone, welcome back. Today we're doing a complete deep dive into archiving and compressing on Linux. Whether you are brand new or looking for a refresher, this video is for you. In today's videos we will do a walkthrough every command, well not every command, but some of the most important ones that you will come across when archiving and compressing on Linux. So let's get started. Before we start, let's clear up some common confusion when it comes to archiving and compression. They are related, but they are not the same thing. Archiving bundle multiple files and directory into a single package while preserving their structure and metadata. Compression reduce the size of the data using an algorithm such as gzip, bzip2, or xz, etc., etc. Most of the time, we archive first, then compress afterward, producing file like .tor.gz or .tor.xz, depending on which tool that you decided to use to do the compression and do the archiving. So, if we take a look at this table, we can see some of the format and what each of them do. So we have .tor, which archive only, no compression. We have qz, .bz2, and xz, which compression format usually apply to a single archive. We have zstd, same thing. And then we have .zip, which archive plus compression allow random access to individual files. And then we have 7z, compress all files together for a better ratio, slower edit or updates. Some of the trade-off that you should be aware of speed versus ratio, random access, multithreading. So speed versus compression ratio, fast algorithm like LZ4 or low level zstd save time but compress less. Heavy algorithm like XZ or LZMA2 compress more but use more CPU and memory. Random access like format like zip or 7z let you extract individual files without unpacking the rest, while tor.gz requires streaming to the archives. Multi-threading tools like gzip is a single thread, but tools like pigz or xz-threads or zstd-t can use multiple core for faster compression. So in summary, short summary would be archive compile files, compression make them smaller. Together they are efficient, portable, and ideal for backups and transfers. So now let's get to do some archiving and compressing. So first thing first, I'm gonna be using the document directory. Let's take a look. There's nothing there's something inside of it, but which is not important. So let's create a folder. We're gonna make a folder, and that's where everything is gonna take place. We're gonna create a folder named demo. Let's call it demo because that's what we're gonna be using for everything. So for simple explanation for what I just did, make dir, create the directory, and then the tilt / is gonna be in the home directory, and then there's gonna be a demo there, and then that's pretty much it. And then we can use the ls to verify that the directory is there. So there you go. As you can see, we have a demo folder. So now let's move to create our file. Now let's make our way into the demo directory. There's nothing inside, so now we're gonna create two files. First we're gonna do echo hello world, and then we're gonna send that to our first file, which is file 1.txt. We're gonna do the same thing again. We're gonna do compression demo, and then we're gonna send that into file number 2.txt, and then we can press ls to view both of our files. So this is what we just did. For explanation for everything, echo print text, the forward greater sign, redirect the output into a file. Cat. Oh yeah, we can do cat. I didn't do that. We can do cat file 1 to read whatever is inside of file number 2, and then we can do the same thing for file number 1. As you can see, this is both of our file. Now let's clear out the screen. So now let's move to archiving file using tor. So this is the first one that we're gonna be using, is the tor. So now, as you can see, we have two files, file 1 and file 2. Now if we do tor -c for compression, well, not for compression, for create the archive, v for verbose, and then f for specify the name that we want. So we're gonna use demo.tor. Now we have to give it the file that we want to archive. We're gonna do file 1 and then we're gonna do file 2. So we press enter, it lists both files, but now if we do ls, we're gonna see we have a archive file in there. As you can see, we have demo.tor, and this is where both of our files are located. We can verify that by typing tor-tf and then demo, and then this is both of our files that are archived inside of the demo.tor. And for a breakdown of the flag, so this is what we did: the C, create the archive, V for verbal, show the for live process. That's why after I finished, we saw file 1, file 2 listed. If the V was not there, we would not have seen these two files. And then the -f specify archive file name. So for you guys who's watching, there's a mini lab that you can do for yourself. We archive multiple files with and without the -v and observe the difference. But like I mentioned, with the V you will see this, without the V you will not see this. But you can try it yourself, give you a chance to practice on your own. So now let's move to compress with gzip. So now that we have our demo.tor, now we can do gzip demo.tor. We don't get no output, but if we do ls-lh, now we do have a gzip compression. Now one thing to keep in mind, guys, using the gzip on whatever file, on whatever archive file you have, will get rid of it. As you can see, I no longer have demo.tor no more. Now it's demo.tor.gzip. There are other command you can use, but I'm using a very simple, which is gzip demo. Gzip, let me see, gzip demo.tor, but you can use gzip with compression level 1, -1, 2, -9. So -1 would be fast, 9 would be the max. We can use the D to decompress. We can use the K to keep original file. We can use the T to test archive integrity to see if everything is going accordingly. And then finally, we can use the gzip to uncompress, or to decompress or uncompress. I don't know if that's a word, but to get our original folder back. So now if I do gzip on the name, if we list our folder, now it goes back to normal. Now we have what we have from the get-go, which was the demo.tor. So that's using the gzip. So now we have other tools we can use. Before we move forward, for whoever's watching again, there's a mini lab you can do. You can try to compress gzip -1 versus gzip -2 and compare the size and speed with the time. I'm not gonna do it, but you guys can try it yourself so you can practice. So now we can do compress with bzip2, which is another tool we can use for compression. So now if we do the same thing again, we're gonna do bzip2-k, which is gonna keep the original file, and then we're gonna pass it the name. You see, with the K, when I use the gzip, if I use the K, now as you can see, now we have two red directory. That's because the K keep the original, which was the demo.tor, and now we have another one which got compressed, another directory which is compressed with the .bz2. And like I mentioned before, the key just keep the original file, and then we can do the bunzip to decompress. So if we do zip2, and then we're gonna pass it the name. So that is a common error you're gonna see, but it's not really an error. It's telling us the demo, because we use the K, that the dash K, the original directory is still there, which is the demo.tar. But now I'm trying to decompress the zip2, because if I decompress it, now we're gonna have two demo.tar. There's a way to fix that. We can use the dash F for force to force it to decompress. Now if we go, now it goes back. Now it decompressed to what we originally have, which was the demo.tar. So zip2 and gzip. I think there's another one that you have to use the F, because if the original file is still there, it's not gonna work. So for you guys, then again, same thing. Mini lab for you guys can do a mini lab, run the time coming on gzip demo.tar versus time bzip2.demo, and discuss the trade-off to see which one is better, which one that you should use. So this is a mini lab for you guys to try for yourself. Yeah, so this is a simple lab for you guys. You can try it yourself. Now let's move to gzip for compression. All of these are the same. They do the same thing, but they all have the trade-off. They all use different algorithm to get the job done. So now we can do the same thing. Let's scroll up. Now we're gonna use the gzip to do the same compression. We're gonna do xz-9e, which is the best compression level we can have. The E is for extreme compression. Now we're gonna use threading 0 to use all my CPU. Threads equals 0. Okay, again to keep the original file, and then the name demo.tar. So gzip reduce the number of threads from 2 to 1. The automatic memory usage limit to 971 MB is still being executed. 1250 MB of memory is required. Continue anyway. So using the gzip, we still got the job done. As you can see, we have the demo.tar.gzip is the same thing. So using the dash threads 0 use all my CPU core for faster processing. Since I have an old computer PC here, I don't know how much of that was being used. I have a i5, so, but for whoever has maybe an i9, more cores, it might be better for you guys. So mini lab for you guys who's watching. Compare gzip, bzip2 and gzip, the size, time, and CPU usage. Discuss which would you choose for archival versus fast transfer. So now let's do the same thing. Now let's decompress our file. So now we're gonna use gzip -f, because the name already exists is not gonna work. And then I can press the tab for auto completion. As you can see, now we're back to our original three file. Well, not file, but one directory and 2 files. So now let's move to zstd compression. So we can use we're gonna use tar dash I zstd na 0 dash 19 cf demo, the name. We're gonna give it the name dash zst, and then the 2 files that I have, which is file 1 and file 2. Now to go over the flag, the tor-i is gonna use external compression. The C is gonna create the archive. The F specify the output file, which is gonna be the demo.tor.zst, and then the X, well, we're not using the X right now because we're not doing any extraction. V for verbose, we're not using that either. And then the T, minus T0 use all CPU, and then minus 19 use max compression. We're not using the dash T. We're not using the C is for output to standard output. Output to std out. Let me see what we have. Let's see. Refusing to write archive. Let me see. What did I do? Oh, I see. There's a dash F somewhere. I see the problem. The command is not correct. There's no space between these two. There's no space between these two. So now it takes some time, and now we got our compression. Now if I do ls, we're gonna see our compression right here. Now we do have a demo.tor.zst. So now we can do the same thing in reverse. We can do the decompress and extract. So now we're gonna do the same thing. We're gonna use tor capital I Z. We use the capital I to use external compressor because we're using the tor. zstd -d for decompress. Oops, oh man, I messed up. Let's go over the -d. Now we're gonna use the xvf. So because we're using the external compressor, you see the single quote. For the zstd, we're using the -d because that's have something to do with this compressing tools. The -d is gonna use it to decompress. But for tor, we're using the xvf, which is gonna do extract. F is gonna specify the name, and then the V is for verbose. So let's go. We're gonna give it the name zst to decompress. If we press enter, did I press enter? If we press enter, we have our two files. ls, nothing happened, but something did happen, because I mean, if I did press the ls and compare the time, you will see even though we have file 1, file 2, the time on them will be different. So the zstd is modern fast multi-thread compression. Compare compression ratio versus gzip /xz. So for you guys, you can, there's a mini lab for you guys to try. Compress the same file with gzip xzsz std, compare size, compression time, and CPU usage. So this is for you guys to try. I don't need the demo that zst no more, so I'm gonna get rid of it. So I'm gonna do so we're gonna, now we're back to our original two files in one directory. So now we're gonna use the zip and unzip to do some compression. Unzip and archive. So we're gonna use the same thing. We're gonna use zip -r9 for max compression, best compression, and then the name demo. We're gonna give it demo.zip, and then the file that we need, file 1 and then file 2. So there you go. Adding file 1 store 0%. I mean, so we have, now we're gonna have a .zip file, demo.zip, which is gonna have our file in it. So we can do demo we can't really go inside of them. That's interesting. All right, I've always wanted to try that. Okay, never mind. So let's keep going. Let's do the unzip. We're gonna do demo.zip. We have to use the -d for extract. So this is a little bit different than the rest. We're gonna use extracted. So now the thing is, when it comes to unzip, the thing is for everything else, when we do the extraction, it usually keep the same name that the directory have. But if we do unzip, we're gonna have to specify a name where to do the extraction from, which is gonna be the extracted directory. So that's what gonna happen. Now we're gonna have an extracted directory. So now if we do ls, now we have an extracted directory, which is where both files gonna be. So if we do dash, I meant to press capital R, but so as you can see, the size is 4.0k because both of our file is very small. So if I do ls-lr, as you can see, we're gonna see inside of extracted, we have both of our file. And then for the flag, the R is for recursive. We use that because in case there were folder included, we can copy folder within folders. And then the -9 is for bus compression. The unzip D is for the for extracted to a specified directory, so a specific directory. So the zip is cross-platform friendly, meaning we can use it on Windows as well. So for you guys, a mini lab will be to zip a folder with subdirectory and compare it with tor.gzip. So that's what the OS is for. Because if we're gonna use the zip with folder with subdirectory, the -o is gonna be needed so it can copy every directory inside of the directory. So now let's move to something a little bit more complicated, which is to do compression and also at the same time to encrypt that same compressed file. So we can use 7z for that. So we can do let's make sure we got you know what, let me see, what do I need first, what do I need before that. Let's see, we do have a backup, that's 7zip. I'm trying to see. Okay, let's remove demo. We don't need demo.zip. We don't need extracted. Let's keep our original let's keep our original file. Let's do rf extracted. So now we're back to our original two file, one directory. So now let's do let's compress and encrypt at the same time. We're gonna use 7z-a to add file, and then we're gonna use -t 7z, which is gonna be for the 7z format, mx9 for max compression, and then we're gonna use the -mhe on for the encrypt, and then now we're gonna do -p. The -p, the password is connected with the p, so it's not like you press -p and then space the password. So everything have to stay together. So let's use 1992. Hopefully that is a strong enough password. I don't know if they have a password strength checker, but that's what I'm gonna use, 1992 for the password, and then the name is gonna be backup.77z, and then we're gonna do that on the demo. Let me see if everything is correct. 7za-tz7-mx9 max compression. Okay, there you go. Everything. As you can see, we have a backup.7z. So the same thing we can use to do the extraction. We're gonna have to do 7zx, which have this is how we do the extraction x, and then we're gonna do backup that z. Let me that z compress 32. Let me see in demo. No file to process. Everything is okay. Size 0, compression 32. Okay, it didn't do anything because the file already there, so nothing actually happened. So nothing actually happened. So now you guys can try extracting with the wrong password. Wait, let me see something. Wait. I think something went wrong. I'm gonna test something out real quick. Let me do something. Let me try something real quick. Let's do secret pwd. Let me see something. Let's see if something went wrong. 7z. Backup 7z is there. If I do 7z, you know what? I'm gonna try something. Let me remove file number 1 and file number 2. I'm gonna add them back again. Let me remove both of them. Let me also remove demo.tar. I'm gonna go all the way at the end. I'm gonna create all of the. I'm gonna create everything back again. Just I wanna check something out real quick. Let's do RF. Okay, now let me do 7zx backup. Let me see something. Something. Oh, I see what happened. So this is not gonna work though, because the thing is it's doing it on the demo, but there's already a demo. I forgot that there's a demo directory. Okay, so that's why nothing is happening. Okay, I see what I did wrong here. I should have because I'm doing this on the demo. Okay, that's why nothing happened. All right, let me go back and add all the other file back, and then I'm gonna do it again because I find out what went wrong. Hello world file 1.txt. I see what happened. 2. Okay, I see. Compression demo. Okay, so now that we are back to business the way everything was. Okay, so now let me remove backup. Let me remove this. So one thing, now let's do let's create the tar again. Let's create the file with the tar dash cvf demo tar file 1 and file 2. Okay, so now because this is using the 7z, the compression and encryption is happening on the demo. We have to go outside of that. We have to do it here, and then do the same thing we did. If you press up, you can see all the past comment. Okay, so this is the comment that we need. So 7z a dash t7z max compression encryption is on. The password is going to be secret password backup 7z on the demo. So now you see, if item to compress 4 before, it wasn't happening because I was not doing it the correct way. So now if I press ls, now we have a backup 7z, which gonna have let's see, we have 1 2 and then the 3 file inside of it. That's nope, let's see, inside of demo, let's see, we have 1 2 3 4. Okay, yep. So that's why it's full file, everything is okay. So now if I do 7z, it might not work because I already have I already have a demo directory. But let's see what message that we're gonna receive if I do backup. Enter the password, which is gonna be secret pwd. Okay, so all the file already exists, so I'm just gonna say to skip all of them, S. So now everything's gonna be the same. But if not, if the demo wasn't there, then we would have a demo directory. So if I go inside of the demo, we would have these again, but because demo already exists, so that's why it asks me if I want to modify, keep, skip, rename, and then quit. But yeah, so that's what happened. So you guys can try to extract with a different password. So now let's move to streaming and network transfer. We're gonna send our folder, our demo folder, into my Red Hat machine. So let me log in into this one. Let me verify that I have SSH running. Come on, let's go. Let me quickly verify. I think SSH is working in here. If I do sudo ufw status, okay, SSH is on. If I do okay, so let's do sudo system ctl sshd. I think that's how I check it. Is it let me see, sudo. Oh, I forgot the status. Oops. Okay, SSH is running, so we can first thing first, let me see, Teddy C is the name. Let's SSH into this machine real quick to see. I don't even know the IP address, to be honest. IPA, which is 192. To see if it's gonna work, we're gonna do 30C at pass. Okay, perfect. Well, now we are into the machine, so we can SSH, which means we can send our file over. Now let's exit out. Okay, so we're gonna be sending the demo file. So now we're gonna do tar-cf. That's how you send file over, and then we're gonna use the demo, and then we're gonna pipe that into our streaming and network transfer. We're gonna use the zstd 0 and then 19 dash C, and then now the SSH, we're gonna do the same thing we did. SSH 30 C, the IP address, and then we're gonna be sending the demo dot tar dot zst. I think everything is correct. Let's see, tar cf dash demo, the folder zstd dash t0 minus 19 dash c, the ssh. Okay, my ask us, let's see, for the password. What just happened? Okay, I see what happened. I see what I did. I see what happened. I see something is missing from our thing. We forgot to do. We forgot some of the. We forgot to do cat. Okay. Okay, now I know we did not get to see any output, but we can I can check my Red Hat machine over here. Let's make this bigger. Let's clear out the screen. Let's see where did the file end up. It is over here. I was able to send this file over to my Red Hat machine using the tar and the zstd compressing tools. So there you go. So the tar cf is compressed, f is for the file name that we sending over, in this case is the demo folder, and then we pipe that into the zst for compression, and then the ssh to send it over wherever we need. So you guys can do the same thing with this mini lab. Stream a directory without creating intermediate file. Check remote server for demo.zst. So as you can see, it was a success on our end. We send it and we receive it. So now let's move to multi-threaded compression. We're gonna use the tar tool for that. Let's see, what should I be using? gz, let me get rid of omf. Let's get rid of backup, and let's get rid of demo that let's get rid of these two. Now let's go back into our demo cd demo. Okay, so for multi-thread we can use tar cf. I have to go back. Okay, I have to go back because we're using it on the demo directory. So we can use tar dash cf demo. Again, we're gonna pipe that into pigz for the compressing, pigz, and then dash p 989, and then we're gonna do demo. We're gonna give it a name, that's gz. Let's see, tar cf dash demo dash p8 9 demo tar. Okay, so if I do ls, we have our .gz. We can do the same thing again, but this time we're gonna use the zst. Same thing, everything stay the same, except we're gonna change the tools that we're using, which is the zstd. Let's see. Oh, it's going to say the directory already exists. Well, it still works. Let's see. No such file. What file that we did not have? Okay, I see what happened. Okay, instead of p I should have used dash t, but it already happened, so I don't think it mattered now. But It's probably not gonna work. Well, let's see, did it work? Okay, yes it did. Oh well. So what just happened? So the top one, we create a tar archive of the demo directory folder, and then we compress it with the pgz, which stands for parallel gzip, using a thread and a level 9 compression, and then we save it in demo.tar.gzip. And the same thing with the second one. We pretty much did the same thing, except we use different tools. We use the create a tar archive of the same folder, compress it with the zstd using a thread and level 9 compression, then save it as demo.tar.zst, and pgz parallel gzip, and then zstd-c8 is a thread. So you guys can try the same thing with compare single versus multi-threaded performance with time. So we at the end of our demo. So now we're gonna check for integrity. So the way we check for integrity is, let's go, let's see, we're gonna use it on you know what, let me get rid of let me get rid of demo.z. Let's use demo.g. Let's get rid of these two. Let's see. Okay, so inside of demo we have let's see, where is this thing taking place? Okay, so this thing is taking place inside of demo. Okay, so it's taking inside of demo. Okay, so we're not gonna use the gzip because we already have a .tar, but we're gonna create the rest so we can check for integrity. So we're gonna use bzip.2. If I use the -k, we're gonna use -k. I'm gonna use demo.tar. What just happened? B. Oh, it's not by, it's B. Then we're gonna do the same thing again with the send, because we didn't get any output. That's mean the integrity and the checksum of our file is intact. So we can do the same thing with xz. Same thing, we didn't get any errors, so that's mean everything is up to port. We're gonna use zstd t0-19 -f to force it, because it's not gonna work because we already have one. So all of our archive and compress is up to point. We didn't get any output of any error or anything like that. So now we can do a checksum. We can do, let me see, we can do SHA-256 sum demo. Let's use the zst. We're gonna send that into demo SHA-256. Let's see, SHA-256 sum, not dumb. Sum demo.zst. That's what we're using. We do have zst, and then we're gonna send the output into demo.sha-256, and then we're gonna compare them. And then we're gonna compare them to make sure everything is up to par. So now we should have a demo. We should have a demo.sha. Now we can do SHA-256 sum-c for comparison. We're gonna use that on the SHA-256. Everything is good. We got the OK check, and this is what we just had, and this is what we just happened. Well, not happened. This is what we just did. So now, because on my test, everything come out good. We got the OK, but for you guys on the other end, you guys can try to co-op the file and then do the same thing to see what output that you will receive. So this is it, guys. I'm not even gonna go over encryption with GPG. I think that is unnecessary, but I'm just gonna leave it here for a couple of seconds in case you guys wanna quickly take a peek. So we can do the GPG symmetry cipher algo AS256 demo tau GZ, and then we can do the decryption with the key with the .gpg, and boom, voila. So I'm not gonna do that because we're at the end, and this is a practical backup script to backup incremental backup save only change file. You can a little script that I created, and then mini lab for you guys: run script multiple times, modify file, observe incremental behavior. Let me see, what did I have? Advanced topic and best practice. Choose compression based on speed versus ratio, multi-threaded compression for large file, avoid compression already compressed file, and always test, restore, and stream for remote backup. So this is it, guys. I hope you guys learned something. I hope you guys enjoyed the video. I know it's been a while. I've been doing a lot of wrestling and jiu-jitsu, so my body is taking a beating every single day. So that's why I have not been able to upload any videos, because trust me, my body is getting a beat up. Okay, guys. So this is it, guys. Until next time, bye bye.